Welcome to everyone here. It was remarkable to walk in here to this jammed and very kind of buzzing room with our first lab day on the Hill. I see at least a couple of our lab directors. Oh, I see more of our lab directors here. That's right. That's right. They're all there now. All right, great. No, yes, here we are. Another one here in the front. Well, anyway, again, so we're very excited about this, and I hope all of you really get a good chance to get around to see all the exhibits. I'll talk a little bit about more about them as well. And as you know, this event is being co-hosted, if you like, by Senators Durbin and Risch, who are very big supporters of our lab system. They do tend to choose favorites, which may be in Illinois and Idaho, but anyway, they are big supporters. I also want to recognize Congressman Fatah here, sitting down here, who, last I checked, does not have a major lab in his district, but has been a tremendous supporter and may have visited 16 out of our 17 laboratories already. So it's really great. And Senators Durbin and Risch will also be able to talk about the new laboratory caucus that they are putting together to focus more congressional support on the laboratory system. I also want to start by thanking now our distinguished panelists, Norm Augustine. I'm going to assume you all know who they are, but Norm, I want to just emphasize, today issued an important report called Restoring the Foundation. I think he had a partner here, Neil Lane, former President's Science Advisor. You want to stand up or no? Oh, you don't. All right. He's Neil. Actually, Neil and I and Harold Varmus we did some damage together in the Clinton administration when we were in various science positions. Anyway, Norm Augustine again today was with Neil released an important report on restoring the foundation, which addresses the basic research enterprise in the United States. I'm sure Norm will say a few words about that. As an American Academy's sponsored activity. And I just note that, of course, Norm was instrumental in the Gathering Storm report a few years ago, and we hope that this report will have at least equal impact, since Beyond the Gathering Storm, as you know, led to some important initiatives here in the Congress. Harold Varmus, old friend, as you well know, former NIH director and now Cancer Institute, and old friend. But Harold has been also since his days here in D.C. In the 90s, a great champion for research crossing disciplines. One of his signature initiatives, I would say, at the NIH, and maybe today he'll talk a little bit about how, for example, our synchrotron light sources serve the life science communities so broadly. Then Jennifer Rumsey and Clark Gellings, I'll mention them together in that they come here, I think, to exemplify the kinds of collaboration that we have with the private sector. Jennifer with Cummins, been a major partner, and I'm sure, again, she will be mentioning things like some of the supercomputing and modeling work for vehicles, and then Clark, of course, with EPRI, talking about all the work that we have done and do with EPRI in terms of electricity sector and grids, nuclear power, a whole bunch of reasons. So areas. So it's really a very distinguished panel. What we'll do is I'll say a few words. Hopefully, Senators Durbin and Risch will say a few words. They are voting at the moment, and then we'll open it up for a panel discussion. Let me just say a few words about the labs and some of the things that we are doing with the labs, with the lab directors. I mean, as you all know, I mean, the lab system has, in many ways, well, actually not in many ways, as factually, has its origin really during and then the aftermath of World War II. But more broadly than just what is now the Department of Energy, I want to say that, World War II, that was a period where the critical role of research, the critical role of science and engineering in addressing our highest level national objectives in terms of economy, security, health, now I would say energy, really became clear, and we all know the story in terms of science, the endless frontier, and the significant increase in our national funding for R&D, and we also all know that the vision that was laid out at that time has proved to be correct. I'm sure Norm and Neil's report will go through that in quite some detail in terms of addressing our economic, security, and health needs in multiple dimensions. At the Department of Energy, we have a set of missions that people in this room probably are quite familiar with, spanning basic research, especially in the physical sciences, but also with major roles in the life sciences. Energy, clearly, particularly the development of clean energy technology. Nuclear security, where we have responsibilities both for the nuclear stockpile and for non-proliferation and counter-proliferation programs. And finally, environmental stewardship, addressing particularly the remediation of the various Cold War production sites. Those are a pretty diverse set of missions in the eyes of many. They are all firmly grounded in science and technology, and the National Laboratory System is the core asset, if you like, for bringing science and technology to bear on all of those missions. And that's why we are increasingly emphasizing, and I think today's event and the exhibits you will see hopefully will carry the message, that we view this as a system with tremendous capacity, and that capacity is brought to bear first on the missions of the Department of Energy, but also on other critical missions in the country. Certainly the labs, and I don't mean only the so-called national security laboratories, but the laboratories are certainly a major asset for our national security, much more broadly than the very specific mission of the Department of Energy. The labs are providing not only research, but also, frankly, vision as to how we address the transformation of the energy system that we need to meet our economic goals, also very importantly, our environmental goals, most especially our challenge in mitigating the risks of climate change. The laboratories are leaders in discovery science, whether it's Fermilab or you name it. I mean, J-Lab and Brookhaven with the Heavy Ion Collider, SLAC, of course, materials at many of the laboratories is a major focus area. Argon and SLAC and Brookhaven and Oak Ridge and other places. I won't go through them all, but discovery science, from nanotechnology down to the quark structure of matter, are places where our laboratories lead, but they do it also by, of course, drawing upon the entire research community of the United States, the academic community, et cetera. In fact, our facilities are serving nearly 30,000 researchers per year across the country, providing them cutting-edge tools to address key science and engineering challenges across the research spectrum. The the laboratories are playing an important role in how we think about developing our strategic programs to address all of these challenges. And that's something that I think we have tried to emphasize, especially in the last year or so, and creating some structures whereby the laboratories are really helping how we think about some of the cross-cutting programs that we need to execute. So, for example, already in our fiscal year 2015 budget request to the Congress, which is still waiting for its final action, Congressman. In that we put forward thrusts such as subsurface science and engineering, a place where we're not probably as recognized as having tremendous capacity, and yet it cuts across so many of our programs, from hydrocarbon production to geothermal to nuclear waste management to carbon sequestration, et cetera. So the laboratories are really helping us in terms of how we think through these kinds of cross-cutting programs that address critical issues. The laboratories are also a place where we can provide enabling tools for research that are important for our mission, but are also important more broadly in the country. Classic example, again, another area that we emphasized in our 2015 budget request. And of course, I cannot talk about our 2016 budget request, so you'll have to extrapolate. But for example, we put forward the next big push in high-performance computing, moving now towards exascale. When I was in the department in the 1990s, as undersecretary, we had the big push towards 100 petaflops scale as one of the foundations of science-based stockpile stewardship. That program, by the way, again, our labs as the key performers, has been tremendously successful. I gave a talk yesterday at the Institute of Peace, as did General Klotz, our head of our NNSA, and noted that, in the late 90s, when that program was still being formulated, there was a lot of doubt about whether we could really sustain the stockpile for a long time without testing. And that has big policy consequences. For example, things like the Comprehensive Test Ban Treaty. Today, here we are 15 years later, 22 years beyond nuclear testing, and it has worked. In fact, our lab directors would say that we understand those systems a lot better today than we did when we tested. So it's a huge science challenge, could only be handled by tremendous integration of different disciplines, and has major policy consequences. As I said, our defense programs advanced that in the 90s. And frankly, the science programs, the energy programs, were kind of derivative users in many ways of the push to the high-performance computing frontier. What's great is today, the role of high-performance computing in our nuclear security programs certainly hasn't diminished. But in our 2015 budget, roles were reversed. 2/3 of the initiative is now from our science and energy programs, and 1/3 from our nuclear security programs. So it's really a great story, and again, this lab system has just been core to the evaluation of all of these capabilities. Another one now that we are just beginning to, perfect timing, that we are beginning to advance from this perspective of cross-cutting, enabling capabilities. In fact, I should have said, on the high-performance computing, not only are our missions being addressed in that way, but of course now it has increasingly penetrated into our industrial sector as a major tool. And now today, and the President, of course, has put a strong emphasis on developing manufacturing. Once again, our laboratories will play a critical role here. Things like, for example, our pilot plant for 3D printing and these kinds of technologies. So I hope that just gives a flavor of our interactions with the laboratories, their role in executing our missions and other important missions for the country, their success in getting us to where we are, and the future that they have, which I think you can see captured in the 14 stations that we have around here that we can all look at more carefully. So with that, I want to welcome Senator Durbin, who, as I said earlier, is one of the organizers of this event and of a new push among his colleagues to highlight the role of the laboratories. So if I may, Senator Durbin.
Secretary Moniz, thank you very much for giving me a chance to join you this afternoon. Senator Risch is, if he's not here, on his way. Here he comes. Jim and I just voted, so we just rushed over here. But I want to thank Jim for joining me in celebrating one of the most valuable pieces of America's innovation system, our national laboratories. Since our earliest days, Americans have believed in the power of science to transform the world for better. The first coin ever minted in our nation bore the motto, Liberty, parent of science and industry. When Thomas Jefferson sent Meriwether Lewis across the continent to map our nation's future in 1804, he gave him a quick education in botany, geology, geography, and the finer points of navigation, and then sent him off with one simple word, explore. In many ways, the Lewis and Clark expedition established the model for partnership between government and science in our nation. In the 210 years since, government support for scientific research has split the atom, conquered space, created the internet, and mapped the human genome. And many of those advancements have been due in part to the work done by researchers at Department of Energy facilities. Since their creation in the 1940s, the labs have worked together to solve some of the nation's greatest challenges in energy innovation, scientific discovery, and national security. DOE's national labs have always been a meeting place for the world's best researchers. Universities from across the country use the labs to conduct research and train thousands of new scientists each year. The labs are also an important part in maintaining the United States' global competitiveness by allowing private companies to use their state-of-the-art resources to test new products, grow businesses, and yes, create good-paying jobs. Boeing, Texas Instruments, Exxon, Pfizer, DuPont, and 3M are just a few of the companies that use the resources at the national labs to perform experiments that the companies can't do on their own. The national labs truly are a unique jewel that helps set the United States ahead in pursuit of new breakthrough scientific discoveries. The Secretary was kind enough to invite me for breakfast a few weeks ago, and we talked about another bill that I introduced called the American Cures Act, which really focuses on biomedical research and growing biomedical research. It didn't take him long to marry the work of the Department of Energy to the work of the National Institutes of Health and the linkage between biomedical research and what is happening at our national labs and in the Department of Energy, which inspired me to go to my staffer, Jasmine Hunt, and say, it's the American Cures Fund and now the American Discoveries Fund. We can't stop with just the biomedical side, as critically important as it is. But today we're really launching a bipartisan effort, Senator Risch and I, with the support of many of our colleagues, to engage our Senate in this new National Laboratory Caucus. The caucus is going to serve as a forum to discuss policy and funding issues that confront the national lab system. I want to thank Senator Coons, Tim Johnson, my colleague Mark Kirk of Illinois, Michael Bennett, Thomas Udall, Martin Heinrich, Lindsey Graham, Lamar Alexander, and Mike Crapo for being part of the caucus, and invite all of my Senate colleagues to join us. One of my main inspirations for forming this caucus, of course, is homegrown, Argonne and Fermi. They're fantastic, and they do such great work, not only in the state of Illinois, but across the nation. I can go through the long list of their achievements, and the people from those labs want me to do that, but in the interest of time, let me conclude by saying, Jim, thank you for joining me in this effort. We have been partners through the laboratories for many years, And now we're formalizing this relationship and moving it forward in our caucus and your caucus in the hopes of building an even stronger coalition for the national laboratories in the future. Thank you very much, Mr. Secretary.
Thank you, Senator Durbin, and it was a fun breakfast. And I also had a great time, opportunity to visit with Argonne and Fermilab back in June. And as you well know, and many of you know, just fantastic things to see there in both places. I do want to now introduce Senator Risch, and I'll note that just last month it was with him in Idaho. We had a chance to tour the laboratory. Many of you may know Idaho is a lead nuclear laboratory, and what they revealed to me there was, even though I had seen bits and pieces, the idea of this kind of end-to-end nuclear fuel R&D capacity, world unique. It was really terrific. So please, Senator Risch.
Mr. Secretary, thank you so very much. I agreed with every single thing you said, every word except the word Idaho is the lead nuclear laboratory in America. In any event, thank you so much. And Senator Durbin, thank you for being a partner on this. I'm honored to be a partner, co-founder, co-chairman with Senator Durbin as we do our best to engage our colleagues in what we are doing here and proceeding to educate our colleagues as to what the laboratories do. Secretary Moniz, I want to personally thank you for taking the time in August to see firsthand how proud we are of the Idaho National Lab and the tremendous world-class work that is being done there. And I can tell you that your visit was inspirational to many of the dedicated Idahoans who work there. As you can see, we're a little off the beaten path there. Don't get a lot of celebrities come through, but I can tell you people were very glad to see you there.
I've been reduced to that.
With their origins in the defense of our nation leading up to World War II, our nation's national laboratory system has evolved into a network that powers innovative research and development. Spanning from coast to coast, the 17 national laboratories contribute groundbreaking scientific research in a myriad of disciplines, including energy, innovation, national security, and basic science research. In order to conduct this research, our national labs are each equipped with unique assets, frequently specific to that lab, be it their location, one-of-a-kind instruments, or most importantly, and the most important asset of all, the superb scientists seeking answers to the difficult problems facing our world. My home state of Idaho is fortunate to have the Idaho National Laboratory located in Idaho Falls. The INL has a rich history dating from the dawn of commercial nuclear power and the launching of the nuclear navy. People are always surprised to realize that Idaho not only has one naval base, we actually have two naval bases in Idaho. One of them is at the INL. Most people are also surprised to hear that the first use of nuclear energy in the world occurred at the INL on December 20th of 1951, when 4 light bulbs came online and were lit for the first time by nuclear energy. We have a great museum there. It's too bad you didn't have time to visit the museum. It's a ways out in the desert, but it really is worth seeing. Today, the INL is the nation's lead nuclear laboratory, as well as a world leader in securing the ever-growing cyber network. The valuable work done at the Idaho National Laboratory lays the groundwork for extending the life of the nuclear fleet, fortifying the grid and wireless networks, and developing advanced battery storage capabilities among many, many other missions. As you visit the demonstrations today, which I hope all of you will see several projects where the INL plays an important role, including a pair of modeling methods that I think are particularly interesting and will be of great interest to the scientists here. They are called Falcon and Moose. We have a lot of both in Idaho. Maybe that's why they named them that. Falcon is the INL's geothermal modeling capability that allows researchers to have a better understanding of the subsurface environment to get the best bang for their buck when developing geothermal resources. Geothermal resources, I believe, in the future are going to be a great gain for the United States. In the area we live, the heat of the Earth, the crust is much thinner, and you're able to get to the geothermal resource much easier. And the INL has been a great leader on that, actually developed a geothermal facility, and if you see it, it'll be the closest thing you've ever seen to a perpetual motion machine, where hot water is taken up, turns a turbine, goes through a pipe, goes a mile and back down so it doesn't cool the water again, and it just goes on and on and on. Moose has really changed the game of modeling and simulation by providing a user-friendly computer modeling process that greatly decreases the amount of time it takes to develop advanced simulation tools. Although originally designed for nuclear fuel modeling and simulation, very important at the INL, the reach of Moose and its herd of applications can go beyond nuclear to geology, chemistry, and engineering. In addition, INL researchers will be demonstrating technologies that identify, characterize, and mitigate cyber threats. As a member of the Senate Intelligence Committee, I am acutely aware of the importance of developing systems that protect our nation's critical infrastructure from cyber intrusion, clearly one of the greatest vulnerabilities that America has today. National Lab Day is a showcase of the incredible research being done by the entire lab system, and more importantly, the collaboration that exists between these 17 laboratories. In this time of tighter budgets, it is important that the Department of Energy leverages the unique assets at each laboratory, fosters new and creative partnerships, and encourages the labs to work together to provide the taxpayer with the best return on investment. In closing, I can tell you that my goal, and I'm certain Senator Durbin shares this with me in co-chairing the Senate National Laboratory Caucus, is to communicate to our fellow senators the importance of these rich sources of innovation. Most senators are not fortunate to have a national lab in their state, and events like National Lab Day are a valuable tool to share the good work being done at the labs. Thank you very much, Secretary. Thank you for being here. Thank you.
Well, thank you again to both senators, and of course, we stand ready to work with you as often as you would like in terms of advancing the work of the caucus. So before we all get a chance to go around to the exhibits, we're going to have a discussion here with our distinguished panel. We're going to ask them to each start off with a few minutes of remarks, and then we'll have some exchanges. Norm?
All right. Thank you, Mr. Secretary. And usually when the Secretary introduces me, he refers to me as an unemployed aerospace worker, which is closer to the truth. But you had suggested that I provide a bit of background on my perspective of the national labs. And I've had the good fortune of chairing the Board of Visitors for the Lawrence Berkeley National Lab for a number of years. And I see the leader here. I serve on the board of URA that, together with the University of Chicago, oversees Fermilab. In a prior life, our company was the M&O contractor for Oak Ridge, and I've had the occasion to serve on many committees and commissions that have been involved with the lab. So I've seen it from a lot of different seen the labs from a lot of different directions. There are two things that really stand out to me about the labs, neither of which is much of a surprise. The first one is the incredible talent base that's been collected in the laboratories over the years. That's a national asset that we need to be awfully careful to preserve. Talent bases tend to age, and they have to be replenished, and I think we need to be mindful of that. The second thing was the importance of the mission of the national labs. And the Secretary's responsibilities, 43% of his operating budget goes to the national security mission, something that a lot of people don't fully realize. Of course, the other better known mission, or more publicly known mission, probably is the energy mission. And in that area, it seems to me we have a great opportunity given to us by the advent of shale gas opportunities for research, long-term research, to have a big impact. It's bought us time. One of the things about research, though, that has intrigued me is that it tends to have payoffs in areas that one doesn't even imagine when they're performing the research. People study butterfly wings and have an impact in biomedical research. There were studies of Weddell seals in Antarctica that have reduced fatalities during surgery. And that's one of the things, much of the research that goes on at the labs, although it's maybe aimed principally at energy and national security, has a huge impact on jobs. And I don't mean jobs at the lab, I mean the jobs that scientists create for the rest of us. The study that the Secretary mentioned, that I've had the good fortune of co-chairing with my friend Neil Lane, that was sponsored by the American Academy of Arts and Sciences. We released that report this morning. Has great bearing on the thing that all of us in this room are interested in. It deals primarily with the economic impact of research that's done at places like the national labs. And the title of the report relates the American dream to basic research. Now, many in this room will say, what does the American dream have to do with basic research? And I would encourage you to go buy a copy of our report and read it. You will find the answer. It's very exciting. Actually, the report's free, so you can't go wrong. But there is a coupling that it turns out if you want to increase the jobs in America by 1 percentage point, you have to increase the GDP by about 1.7 percentage points. And there have been studies, one of which received a Nobel Prize, that show that between 50 and 85% of the growth in the GDP is attributable to advancements in two areas, science and technology. Such is the importance of those things. One might say, well, if it's so important, why won't industry do the research? Why do we need national labs? And the answer is that in many cases, industry not only won't do the research, it can't really do the research. The pressures of the marketplace really preclude industry from taking on very long-term, very high risk, even if it has very high payoff research, which is exactly why we need national labs. Another reason is that much of today's research depends on huge facilities, and each company can't buy those facilities. We need someplace such as the national labs that can provide those facilities. So I would just conclude these brief opening remarks by noting that America can compete, whether it's in energy, national security, or in the economy, particularly in the economy. You only have two choices. One choice is to be the lowest cost provider, and the other choice is to be the most innovative provider. That's the question whenever you go to the grocery store or the hardware store that everybody faces. Turns out that, as we talked about at the American Academy's meeting this morning, there are 7 billion people on this earth, half of whom live on $2 a day. I don't think we want to compete based on cost, because the impact on our standard of living will be devastating. We have to compete on innovation. That's our only choice. And the national labs really deal with two of the most important, two of the three aspects of innovation. One of those is new knowledge, one is talented people, and the third is an environment that's conducive to innovation. So in my mind, the national labs play a very important role as a partner to industry.
Thank you, Norm. Harold, why don't you go next?
Am I audible? Yes. About 6 weeks ago, I was invited to go out to the Los Alamos National Lab to give this year's J. Robert Oppenheimer's memorial lecture. And that was an occasion that gave me some time to think about the relationship of the national labs to the medical science that I've practiced and tried to direct over the last 40 years or so. There are at least three categories of activity in which the national labs and biomedical research have been mutually supportive. The first is just frank, outright scientific collaboration. There are many examples, but the one that is perhaps paramount is the work that was done together between the NIH and DOE in the Human Genome Project. The Genome Project, in a sense, began in the Department of Energy, emerging from an interest in the effects of radiation on DNA. But depended a lot on technologies developed in the national lab, including Los Alamos. And indeed, the former employee of Los Alamos who took me on a tour, a hiking tour, out to Oppenheimer's cabin up in the mountain, in the Pecos Mountains, was in fact one of those folks who separated chromosomes by size and allowed us to reduce the task of sequencing the genome in the early days by beginning with fractionated chromosomes, a technique that was still in its infantile stages in the 1980s. The second area in which there's been very strong synergy is in the development of new technical capacities. Medicine and biology have been dependent on physical methods since the early days of modern biomedical research. Think Rankine and the X-ray, or electrocardiograms and electroencephalograms. More recently, there is a whole spectrum of technologies, mass spec, nanotechnology, sophisticated use of lasers, and many others. But the one that's been in the eye of the NIH with greatest impact is the use of beam lines from your synchrotrons for the performance of X-ray crystallography. And indeed, it's not just a matter of loyalty and trying to usurp the technologies that are available through DOE labs, but actually transfer of greenbacks from our agency to DOE. And I'm sure Ernie remembers.
Not enough.
The day, very, very ungracious of you, Ernie. But I'm sure Ernie remembers the days in the 1990s when we helped to support the development of beam lines. And in more recent years, some of our institutes, the National Institute of Imaging and Bioengineering and the National Institute of General Medical Sciences have both been supporting many of the national labs around the country that have been upgrading their beam lines and providing services to many of our investigators. The third area is one that you may find surprising. And that's one that becomes a special responsibility that I bear as the head of the National Cancer Institute, the only agency within HHS, as far as I know, that has a congressionally legislated, federally funded research and development contract that we execute largely at Frederick, Maryland, through what we now call the Frederick National Lab for Cancer Research. Since I returned to the NIH campus a few years ago, we've been trying to upgrade the way in which that facility works and make it more like some of your national labs. And I'm grateful to many of you around the room for providing insight into how you run your contracts, how you ensure that the best possible science is being done. Our Frederick National Lab Advisory Committee spent a couple of days at the Lawrence Berkeley Lab recently. I learned from my colleagues at Sandia and Los Alamos and Brookhaven and Oak Ridge and many other labs about new ways in which we can try to engage our broader scientific community and yours in the operations of our Frederick National Lab. And for these lessons and our ability to try to emulate the great work that's been done in the national labs, I am very grateful to you and to the Secretary. Thank you.
Thanks, Harold. And let me just repeat that actually those very modest transfers of funds, no, but it's actually very visionary because that really made it clear that this kind of collaboration across agencies, across disciplines was so critical. And I think today, I believe, I stand ready to be corrected, but I believe about a third of our, I'm getting a nod there, from about a third of our work at the synchrotrons is in the life science arena. So that was a very visionary and highly leveraged investment, Harold. Thank you. Jennifer?
There we go. Good afternoon, everyone. It's my pleasure to be here and have the opportunity to represent an industry perspective on the value of the Department of Energy and the national labs. As Secretary said, I'm Jennifer Rumsey. I'm the Vice President of Engineering for the engine business at Cummins. And for those of you that aren't familiar with Cummins, we're a global engine manufacturer headquartered in Columbus, Indiana. In 2013, we produced just shy of 1 million engines globally, ranging from 2.8 liter displacement to 78 liter. So that's pickup truck, small commercial van to massive mining haul truck, for those of you that don't think in engine displacement like I do. And really, for us in the last 2 to 3 decades, the key challenge for us has been how do we continue to innovate in our products in a way that allows them to meet increasingly lower levels of emissions to ensure that we have environmental sustainability. And as we do that, both for Cummins and those in our industry, as well as for our customers that are buying those products, that are using them as a core part of their business, we've got to do that in a way that meets cleaner emissions, but also maintains competitiveness for them and the ability to have a successful business. And one of the things as we think about innovation that we think is core to doing innovation is what we call deep technical expertise. And really, when you look at the national labs, that's one of the key things that they provide to us is that incredibly deep expertise and tools in certain areas that allows us to make breakthroughs and innovation in some of our product areas. And so I just wanted to highlight a couple of quick examples of how we've used that in our industry. So the first is some work that's been done over the last number of years with Sandia National Lab and a multi-institution collaboration looking at combustion fundamentals and trying to understand combustion at a very basic level so that we can develop combustion systems that have low emissions. And through that work, we've also developed very advanced modeling techniques that now with supercomputers allow us to develop our combustion systems for all our engines using these tools and meet low emissions, at the same time good fuel efficiency, and have allowed us to have cost-effective solutions to some of the environmental goals that we've set for ourselves. Another example is some of the work that we've done with Oak Ridge National Labs, which includes a number of areas, including after-treatment systems and understanding the fundamentals of after-treatment systems, as well as material properties and advanced manufacturing that ensures that we continue to be cost competitive as we look at developing more fuel-efficient, environmentally friendly products. And these really all have come together for us in, one of the Department of Energy programs that Cummins is just completing called SuperTruck. For those of you that may have seen that, there was a Class 8 truck that Cummins developed in partnership with Peterbilt and Eaton. And there were others in our industry that also participated in this program that really pushed the boundaries of how you develop these technologies and integrate them in a way that really transformed efficiency in a Class 8 pickup truck. So that truck was able to demonstrate 10.7 miles per gallon, which for a fully loaded Class 8 truck is pretty dramatic. It was a 75% reduction in fuel consumed over a typical drive cycle and a more than 40% reduction in greenhouse gases. So we're really proud of the work that we've done in partnership with the labs, and we think that that work is enabling us to keep innovative products that are ensuring the success of the industry that we support.
Great, thank you. And I would, I think, observe correctly that Cummins was really a leader in terms of the application of large-scale modeling and simulation in this engine context, and apparently with a competitive advantage. That's great. Also, I might say the SuperTruck, I just want to emphasize, it's not a fiction. I mean, I actually sat in the cab of this Class 8 truck, although I wasn't allowed to drive it. But anyway.
So did President Obama.
Clark?
Thank you, Mr. Secretary. First, let me introduce what the Electric Power Research Institute is, EPRI. It's an independent nonprofit center for public interest research. EPRI has over 1,000 utility and energy company participants in 40 countries. EPRI cannot and does not do its own basic science work. We depend heavily on our national labs in order to provide the early stage research and development needed in order to evolve the innovations that are going to be critical, continue to be critical, to provide our society with clean, reliable, and affordable electricity. And what we do, we see our role as more of a technology accelerator, taking the output of the lab's technology work and moving it towards commercialization. We do that in collaboration with our members, and that gives us the opportunity to help the labs leverage these 1,000 entities that I referred to. Of course, we involve other industry stakeholders as well in this process. I'll give you just 3 quick examples. I'm going to feel really bad here because I could find an example from just about every lab in the nation, a substantive example. Idaho was mentioned, so let me suggest EPRI is a member of the Battelle Energy Alliance, which has been managing the Idaho National Lab since 2004. In our collaboration there, what we've been doing lately is conducting essential research which is needed to extend the life of our nation's nuclear plants from the current 60-year licenses to 80 years. The work is materials related. It's quite complicated. If we don't succeed along with the lab, we will see CO2 emissions in this nation increase by as much as 20% over that period of time. It is a critical problem that needs to be addressed. And then let me mention NREL, the National Renewable Energy Lab. With them, we've established a national incubator initiative for clean energy. One of the problems with innovation that we've seen in the clean energy space is that there's many great ideas out there. They come from a variety of corners, universities, small businesses, and so on. But most folks don't know how to move them forward into the commercialization space. So what we're doing with NREL is we're devising a way to make that happen. And then I'll just mention one more. It's what we call our critical power program. And we've got 4 national labs involved with us there in the development and testing of technology: Oak Ridge, Lawrence Livermore, Sandia, and INL again. In this program, the focus is to find those technologies that would make a real difference in reducing or increasing reliability and reducing power quality events. And if you don't think that's important, let me suggest to you that currently we're seeing about $186 billion a year being lost in our economy because of poor reliability and poor power quality. Thank you.
Thank you, Clark. And the partnership really is very, very close. And as you know, we face a lot of challenges right now in our electricity system, integrating more intelligence into it, smart grids, cybersecurity, and many other challenges. And so it's really important that, again, we have this partnership with the private sector and the utilities, in this case through EPRI. Maybe I'm going to ask a couple of questions and then see if there are a few questions from the audience, and then we'll be able to do our tour. Norm, you actually mentioned the issue of renewal of workforce, researchers. It's obviously relevant to the laboratories, some of our programs more than some others, in fact, but it's also a broader societal challenge, I think, at the moment. I might just give one anecdote, which was when I visited one of the nuclear security laboratories, weapons laboratories, and had some snippet of unclassified research. It was very interesting that the examples were supported by 4 different DOE offices: ARPA-E, Energy Efficiency and Renewables, Biological Energy and Biological and Environmental Research, and Nuclear Energy. They were all young researchers. The projects had all started with the lab director's R&D discretionary fund and then been picked up by offices, none of them the nuclear weapons program. But that's a way of, obviously, in addition, of bringing tremendous talent into the laboratories. Do any of you see ways in which we, in particular, the Department of Energy, can help in addressing this renewal requirement? Norm, I think it starts with you.
Okay, well, I'm happy to take that one because I think it's so very important. And today, as many people here know, 2/3 of the PhDs that are granted by U.S. universities go to students who are born abroad, and increasingly they're going home. And one of the reasons they go home is after they get their degree, our immigration policies drive them home. One of the things we need to do is to keep more of those talented people. The other thing we need to do is to produce more homegrown people who are interested in science and engineering. And as you could tell, being an engineer, I like statistics, but the NSF looked at 93 different nations and asked the question of where do you rank in terms of the percentage of baccalaureate degrees that are awarded that are in, say, in engineering or science. And the U.S. ranks 79th in each science and engineering out of the 93. The country that we're closest to is Mozambique. And so one of the questions is, really the Secretary's question is, how are we going to compete in the future if this is if the economy and so much else is based on advancements in science and technology? And I think one of the things that the department can do, and that it does do, but could do a lot more of, is focus on very young people in this country and see if we can't get some excitement about science and technology. That candidly, the image of scientists and engineers is not that great. It's pretty good among kids till they're about fourth grade. Those kids love, the two things that turn them on are the space program and dinosaurs, and we're short on dinosaurs. And so one of the things that, some of this exciting stuff that goes on in the national labs that we could use to inspire young people to help the teachers who teach them.
Mm-hmm. Any other comments on that? Or I'll move on to my next question. Okay, maybe for Jennifer and Clark in particular, there's been a lot of discussion recently, and including a recent report on suggestions that we might try to increase our technology transfer profile. I've always emphasized that technology transfer cannot be the prime mission of the Department of Energy, but it's a very, very important activity, and one that we'd love to find some new ideas to strengthen. You've been doing it. Do you see ways in which we can perhaps improve our capacity for working with industry and doing technology transfer?
Thank you, Mr. Secretary. First, a compliment. I've seen a real positive move in the last 3 years among the labs collaborating with one another, and that gets to my suggestion, do more of that. That really is a very effective way not only to fertilize, if you will, the technologies that are in the incubator stage, but also it aids greatly in technology transfer because the connections that are made and so on. I would say that the single most important thing you could do to improve further technology transfer is to continue to increase communication. I don't know everything that goes on that might be applicable to the electric sector. We actually make quite an effort with a group of young people we have called Innovation Scouts to try to reach out and really keep an eye on what's going on in the national labs, but I'm not sure that's sufficient. So if I don't think we have a serious problem, but if you're asking where could we make some marginal improvement, I think absolutely it would be in communication.
Mm-hmm. I think we've heard often that our IP portfolio, for example, is not as well known and well promulgated as it might be. So that's a good suggestion.
Yeah, I agree with the suggestions. I think the ability to do some of both the longer term projects, the CRADAs together, as well as work on more near term and very responsive type of projects together as one key way to increase that ability to commercialize some of the work. And then, for us, we're really looking at commercializing in our own business, but I think there may be opportunities for some of the technologies to think about smaller business engagement and how you might enable the development of those through new business incubations. And there, there's trends in a lot of universities to do that type of thing. So I don't know if there's parallels there for the labs to consider.
There certainly are some examples in Albuquerque, for example, with some of that and small companies getting started. But yeah, we probably need to have it more system-wide. Yeah, thank you. Yeah, Harold. Yeah.
Just one brief comment, Ernie. I think this might be a place where DOE and NIH could actually have some useful, if limited, collaboration. We, of course, have a major effort in technology transfer at several levels, both getting our results into a more product-oriented sphere, also engineering collaborations with industry through cooperative research and development agreements. I think some of our program officers who do technology transfer and people at universities supported by the NIH who have been doing this for years might provide a useful set of exchanges with your own technology transfer offices, and we'd be interested in doing that. The other place where that kind of exchange might be useful is thinking about small business innovation awards, which, of course, we're mandated to do, as you must be, and we've had a number of interesting new programs
Yes.
that make a bigger effort to foster development all the way to the product level, and that might be another place where NIH, and specifically the NCI, which has a very, very large portfolio, could be useful.
Okay, well, let's get people together on that. And I'll just ask one last question. I may as well ask a question that's kind of a little bit outside the box. If I think in terms of your remarks earlier, Harold, in terms of the various intersections in life science and biomedical work, et cetera, and some of the great successes, actually, from that, and I look today and, what's kind of the biggest buzz right now in administration is the BRAIN initiative. Do you see the kinds of capacity in the laboratories as being helpful for something like the BRAIN?
Let me first point out that this is not my own area of expertise, nor is the National Cancer Institute particularly engaged in the BRAIN initiative.
I know.
Having said that, though, I know enough about neuroscience, and even if just expressed in the context of cancers of the brain, to know that some of the physically based technologies that you folks work on are inevitably going to be incredibly important. The brain is a very, very large organ with enormous numbers of connections, with 10 to the 11th cells, and connections that average about 1,000 per cell. So that's a very large number of interconnections, and we are struggling at the moment trying to put all genomic information derived from cancer genomes into a database that allows us to make interpretations, and we seek help from the computational communities that you sponsor for help with those kinds of things. And I'm sure that when the BRAIN project begins to crank up in a major way in trying to create a picture of the interconnectedness of brain cells, that interactions between our computational communities and use of some of your physical facilities will be critical.
Mm-hmm. Great. I mean, I can assure you we have our hands full with nuclear security and energy and basic science, environmental remediation. But again, the extent to which our laboratories can also be used as a national resource is one that we're certainly.
Of course, the other area is in imaging, where we already collaborate extensively, and
sensors
and imaging will be critical in the BRAIN project.
Great. Okay, well, look, I think we're kind of getting at the end of our time, but maybe a couple of questions. And by the way, I see Chairman Simpson has joined us, and welcome. We have a strong Idaho delegation here at the moment, right? Are there a couple of questions for our distinguished panel? Neil, this is your time to nail Norm. Right? Questions? Anyone?
Dave Malakoff, Science Magazine. Norm, your and Neil Lane's report today makes a big point of federal investment in basic research. You set a goal pushing it up to 0.3% of GDP by 2032. The labs, of course, are straddling that mix between basic and applied research, and I was wondering if the panel had any thought in terms of spending priorities in tight times. Where should the labs be along that continuum?
It's a great question. Harold could lend a lot to that discussion from his perspective, but the American Academy's report focused on basic research, largely on curiosity-driven research, and we set a goal that 10% of the nation's R&D should be devoted to basic research. And the good news is we spend so little to begin with that to increase it by a larger percentage is not that difficult in the big grand scheme of things. Our basic goal is 3.2% for R&D, and like a tenth of that, or about 0.3% of the GDP going to basic research. And that part we really focused on, not so much the translational part. So the translational part would come on top of that out of the other 2.9%. And we did not set a specific goal, but your point is so important, because if you do all basic research, you don't change the world much unless you have some translational research. If you do all translational research, you don't have anything to translate. So there's a delicate balance that I think I've never found the equation to tell you how to balance it. It comes down to the judgment of people like Harold who live in this world, or Ernie.
I would just add, in addition to the kind of the curiosity-driven research, and our Office of Science does a lot of that, and I think, generally speaking, quite well. But I also would emphasize, in recent years, the last 5-6 years, for example, also the kind of strong stance also in what's sometimes called Pasteur's quadrant. So, for example, our Energy Frontier Research Centers are a good example, both labs and universities, where the community has defined really the science challenges for future energy technologies, supported those with kind of 5-year sustained awards, so that the science is being done that underpins some well-defined technology challenges in the energy space. So it's really a great, I think we need to have the spectrum of research. So I also want to know Congressman Hultgren has now joined us. We seem to have a concentration in 2 states here today from our members. But is there a last question? I hope there is. Somebody. Last question? Everyone's overwhelmed by our panel. All right, well, okay, with that, let me first of all thank the many lab directors and their staffs who are here today for having made the effort to put together this system-wide set of displays in terms of what the labs are doing on important problems in our mission space, and in terms of developing core capacities for the entire American research establishment and industry as well. And then, of course, our distinguished panel, if you could join me in giving them a hand as well. And we are all free now to become educated in the back of the room. Thank you.